Welcome to solverfy.
Looking at more problems on friction, consider the diagram shown in the board. We want to determine the equivalent of static friction, okay, at the touching surfaces. That's a shaft and a bushing, okay. Now, in the problem, it is assumed no slip, so we can just go ahead and solve the problem by you can apply moment, solve it so that if we take moment about point O, it's going to give us 0, and we have the 200 IB force there. 200 times arrow, the radius of the bushy that is given, plus arrow f. Of course, arrow f will be gained on this side. Arrows of f will be gained on this side, okay, due to the loading of the system, okay, plus, sorry, minus 200 and 215 times arrow plus arrow f. Arrow f is the radius of the friction circle, okay. Then everything is equal to 0. So if we solve this out, we are going to arrive at our arrow f to be equal to 0.0407. Okay. Now we know that for our friction radius, the relation is arrow f is equal to arrow sine um, the angle of kinetic friction, which is that is there. Okay. So if we plug in values in there, we already know that our sine is will give us equal to Rf, which we have already found out, over arrow, the radius that is there. Okay, the radius of the shaft. Okay, so this is the radius of the shaft. Let's just call it Rs. Okay, Rs, the radius of the shaft. Okay, so when we do that, we are going to have arrived at your value. The radius of the shaft is actually 1 inch. Okay, so when you plug in your value, you're going to have it to be 0.0407. You can get the radius of the shaft from the diameter that is given there as 2 inch. So 2 inch. So when you divide it by 2, you have 1 inch. So this is what you're going to have. So if you take the arc sign of this value that we just got in 0.0407, you're going to arrive at equal to, sorry, I just put it here. You're going to have your angle to be equal to 23, sorry, 2.33 degrees. Okay, but of course we know that mu that we are looking for, that mu s, coefficient of static friction, is equal to tan mu, sorry, tan phi k. Okay, so when we look for the angle, when we look for this one, we are going to have it from the angle that we have already gotten, which is this one. We are going to arrive at mu to be equal to 0.0407. 0.0407. So that's the value.